In this video, we present HandNeRF, a novel framework to reconstruct accurate appearance and geometry with neural radiance fields for animatable interacting hands. Given a set of multi-view images capturing a pose sequence of a single hand or two interacting hands, HandNeRF models the scene in a unified manner with neural radiance fields, enabling the rendering of novel hand poses from arbitrary viewing directions. Here we present a quick overview of HandNeRF. First, an off-the-shelf skeleton estimator is employed to parameterize the hand poses. Then we design a pose-driven deformation field to establish correspondence from those different poses to a shared canonical space, where a pose disentangled NeRF for one hand is optimized. Meanwhile, we further leverage the pose priors to generate pseudo-depth maps as guidance for occlusion-aware density learning. Moreover, a neural feature distillation method is proposed to achieve cross-domain alignment for color optimization. As the most popular implicit representation in neural rendering, neural radiance fields, aka NeRF, has exhibited stunning results in various tasks since its first introduction. The original vanilla NeRF overfits one static scene by design. Therefore, it cannot model time-varying contents. Also, it requires massive multi-view samples for high-quality modeling per scene. Inspired by previous works on the neural rendering of articulated objects, we design a pose-condition deformation field that warps the observing rays passing through both hands to a shared canonical space. The skeleton-driven transformation from the nanomesh fitting is employed as a strong prior for the deformation field. An additional pose-conditioned error correction network is introduced to account for the inevitable errors caused by the interpolation and the parameterized model. To enable the complementation of geometry and texture for left and right hands in textureless or rarely observed areas during training, we also introduce a hand mapping module in practice to align the left hand with the right one, thereby establishing a unified modeling of canonical space for both hands. In order to render two interacting hands while the canonical NeRF only models one single hand, we perform object composition by warping a straight observing ray with two different solutions produced by the deformation field, depending on the corresponding poses of two hands. The colors and densities of the two sets of deformed samples are produced by the shared canonical NeRF, which are then resorted and integrated using volume rendering. However, such design is far from enough for interacting hands. Our composition strategy will exhibit poor performance without a relatively accurate geometry prediction. Therefore, we establish 2D depth supervision on the optimization of 3D density. Once the pose hand mesh is obtained, the depth of each pixel from a specific view is freely available as a byproduct. We then use it to build a pseudo-depth map as the ground truth for the training view. Moreover, to improve the rendering quality for unseen views or poses with sparse training views, we adopt a cross-domain student-teacher paradigm to align the 2D image features produced by a pre-trained extractor with the corresponding sample features defined in 3D space. Therefore, contextual cues can be implicitly introduced to the optimization of color field owing to the receptive field of the feature extractor. Extensive experiments are conducted to verify the merits of our proposed HandNeRF. We compare HandNeRF with three baselines that explore NeRF for human body. Since all the baselines are for one single articulated object only, we extend them with the proposed composition strategy to integrate two independent canonical models for both hands. We report a series of new state-of-the-art records under two different settings, including novel view synthesis, as well as novel pose synthesis for pose generalization and adaptation. The superiority of our proposed unified modeling can be evidently observed from the qualitative results. Even trained with extremely sparse views, HandNeRF can still achieve high quality for interacting hands. For comparison, some baselines fail to converge properly on interacting hands and render mask-like textureless images. Here we also provide some videos rendered by HandNeRF for the continuous transformation of views and poses. The synthesis results prove that our method is able to handle various complex interacting poses and maintain excellent multi-view consistency at the same time. Thanks for your time.